All right, we're going to begin this lesson on quadratic functions. All right, we've talked a little bit about quadratic functions before. You guys probably remember ax squared plus bx plus c. You guys probably remember that as the standard form of a quadratic expression. We call that in this chapter quadratic form, but again, you guys are probably more familiar with calling this standard form. All right, which might be a little confusing just because you're going to see eventually there's another thing that this textbook calls standard form, but we'll be specific once test time comes on which is which. But quadratic functions represent on a graph parabolas that open up or down, right? So this is a parabola that's opening upwards. And you can see that it has the same shape that we've discussed in the previous lesson, in lesson 2.5, but there's a couple more characteristics of it that we describe in this lesson here, right? So the vertex, we call this point right here. The vertex is either the highest or the lowest point on a parabola, right? So for example, if I had one going downwards like this, right? This point right here is the highest point. We call that the maximum, right, of our parabola, right? But either way, they represent the vertex, and we use the letters H and K to represent that point. We also have an axis of symmetry, right? That just means everything on one side of your parabola is identical mirror image of what's on the other side, right? So for example, this point right here is exactly the same as this point over here, just 2 units, right? It looks like it's 2 units from that axis of symmetry. And if I go 2 units in the other direction, we get that exact same point, right? Even if you go, like, let's say up here, right, to this point right here, if you go, actually, wait, I think it's this point, right? I think this point right here, if you go 1, 2, 3 units over, you reach the axis of symmetry. And then if you go 1, 2, 3 units over, you reach your parabola, right? So the left and right side of your axis of symmetry is going to be equally spaced apart. Same thing with this line that this parabola that I drew, right? Everything on this side is going to be the same units apart on the other side, right? So something like that. Now, with quadratic functions, we can mathematically find the vertex if it's in quadratic form. So if it's in ax squared plus bx plus c form, then you're going to use this little formula, x equals negative b over 2a, to find the x coordinate of your vertex. And then once you get that number, you're going to plug it back into your function to find the y coordinate. All right, and to actually sketch a complete graph of a quadratic function, you can plot the y-intercept. That's usually the next easiest point to find, but if you need additional points, you can either plug in some numbers into your function and get an ordered pair, or you can use your x-intercepts, right? This is what I was mentioning before with standard form, right? Standard form, I also call this vertex form. All right, now this, I like to call it vertex form just because it gives you the vertex right away, right? So this is the same A that was in quadratic form in the first slide that we did, right? So this is the same A as the ax squared plus bx plus c, but this time we have the h and k of our vertex already in our equation, right? And once again, our vertex we represent with the letters h and k. And we have an axis of symmetry or a line of symmetry at x equals h, right? So it is that vertical line crossing the x-axis at h. All right, starting with this first example. I know it says example 5, but we had to cut out some examples from the set of notes. Let's just start with this one. This is an example of a quadratic equation in vertex form, right? So if you remember, vertex form from the previous slide is a x minus h squared plus k, right? And then hk is your vertex, all right? So just by looking at this equation, there's nothing in front of your parentheses, so I'm going to assume that a is 1, right? And then looking inside of your parentheses, I have an x plus 2. X plus 2 is the same as x minus negative 2, right? So just to get it to look like an x minus h, you can write it like this, and then you can see that there's a negative 2 in your vertex form. So my x coordinate of the vertex is negative 2. The k value, it's plus k, plus negative 3 is still negative 3, so I'm going to write negative 3 that I see right here, right? That is your k value, all right? And, you know, even before this lesson, right, even before learning about vertex form, you guys have learned how to graph something like this, like a rough sketch of it, right? But this is when I told you guys that we get to be a little bit more specific, right? Because you guys know on the inside that that is a translation 2 units to the left and 3 units down, right? So I know my vertex, when I go to plot it on the graph, is going to be somewhere right there, all right? Your axis of symmetry, to mathematically find it, if you have your vertex, all you have to do is set x equal to the x coordinate of your vertex. So I get a vertical line at x equals negative 2. All right, so then that is my axis of symmetry. Finding the x-intercepts, you're going to set your function equal to 0. All right, so let me say this, right? So it's going to be f of x equals 0. So I'm going to take your function, right? So this one, x plus 2 squared minus 3. And you're going to set that equal to 0, right? So what we want to do is solve by square rooting, right? It's already set up to where you can add 3 on both sides and then square root both sides. So I get x plus 2 squared equals 3. And then we can square root both sides, and then I get x plus 2 equals plus or minus the square root of 3. And then let's subtract 2 on both sides, and then I get x equals negative 2 plus or minus the square root of 3. All right? Looking at a graph, you're probably not going to have to accurately graph those points. I know that that's kind of a strange point. If you put it in a calculator, it's going to give you some decimal answer. But let's put it in an ordered pair, right? An intercept is always going to be written as an ordered pair. So it's going to be negative 2 plus or minus the square root of 3, comma 0. To find the y-intercept, what we can do is we can plug in 0 for x. So I want to find f of 0. So f of 0 in this case is going to be 0 plus 2 squared minus 3, which is going to get you 2 squared minus 3. So 4 minus 3, so 1, right? And as an ordered pair, that's going to be 0, comma 1, right? That's an easy point to plot, so I'm going to plot that point over here. And then from here, this is actually enough information to sketch our parabola, just because we can go 2 units over on the other side, and then we're going to get the same exact point, right? That's what our axis of symmetry does, all right? And then that's enough information, right? This is a pretty accurate sketch of our parabola. We don't really need more points, right? We know that our x-intercepts are going to be somewhere right there. But yeah, that's it for this problem. All right, now this is a problem that's in quadratic form already. So to find the vertex, it's not going to be exactly the same thing. We're going to have to do h equals negative b over 2a, all right? And then in this case, a is 1, b is negative 6, and c is negative 14, right? So let's plug these numbers in to get our h coordinate. H equals negative 6 over 2 times 1. Negative 6 is 6 over 2 is 3. So that means the x coordinate of my vertex is 3. To find the y coordinate, I'm going to plug in 3 into this function, right? So it's going to be 3 squared minus 6 times 3 minus 14. And so that's going to get us 9 minus 18 minus 14, which is negative 9 minus 14. So negative 23, we get 3 comma negative 23, right? It's not really going to fit on our graph, so I'm going to let it go by 4s, right? So negative 4, negative 8, negative 12, 16, 20, 24, right? And I'm going to say that it's at 20, no, sorry, not there, right? 3 1, 2, 3. Negative 23 is somewhere right there. Our axis of symmetry, once again, you just use the x coordinate of your vertex. Once you have it, it's going to be x equals 3. And it's going to be this line that cuts our parabola in half. X-intercepts, if you can factor this, you would factor it. I actually don't think this one factors, so you would have to use completing the square or the quadratic formula. I'm going to complete the square, so I'm going to do x squared minus 6x plus a blank equals, we would have added 14 to the other side, plus a little blank, and then in this blank is going to go b over 2 squared, which is 6 over 2 squared, which is 9. All right, so add 9 to both sides. And then this is going to factor as x minus 3 squared equals 23. And then you would square root both sides. And then you would get x minus 3 is plus minus the square root of 23. And then add 3 to both sides, and then you get as your x-intercepts where x crosses 3 plus minus the square root of 23. All right, once again, we don't really have to graph that, all right, comma 0, right, always as an ordered pair. We don't really have to graph that. That's kind of a strange point to plot. But let's find our y-intercept, right? And that's going to be f of 0 when we plug in 0 for x. So this is going to be 0 squared minus 6 times 0 minus 14. And that's going to get us negative 14. So our y-intercept is going to be 0, comma, negative 14. Also notice is that it's always going to be, if it's in this form, your c value, right? So negative 14, just because the x's are always going to cancel out when you plug in 0. So that's another way that you can think of it and get your answer pretty quickly, right? So I'm going to plot negative 14. Since we have an axis of symmetry, I know that I can go 3 units in the other direction, right? And then I know for sure it's going to look something like that, right? So 3 points is perfect, right? If you feel like you need more, pick more. But otherwise, this is perfectly fine the way it is. All right, here's another example that is in quadratic form. So ax squared plus bx plus c. Let's label every part of this equation, right? This negative in front, I'm going to treat that as negative 1. And this is a. This positive 6 is going to be the b, and this negative 8 is going to be the c. All right. Now, to find the vertex, again, we're going to use h equals negative b over 2a. And so we're just going to plug in, right? Negative 6 on top over 2 times negative 1 is going to get you negative 6 over negative 2, which is a positive 3. So that means the x coordinate of my vertex is 3. And then to find the k coordinate, you're going to plug that in to your function. So I'm going to find f of 3, right? And f of 3 is going to get you negative 3 squared plus 6 times 3 minus 8. And then that's going to get us a negative 9 plus 18 minus 8. And that's going to get you 9 minus 8, so 1, right? So we get a y-coordinate of 1, right? Let's plot that on our graph. It's going to be right there. Our axis of symmetry, once again, is just going to be where x equals the x-coordinate of your vertex. So it's going to be x equals 3. And I'm just going to go ahead and plot that on the graph, right? This vertical dotted line. All right. And now let's find our x-intercepts. We're going to set our equation or our function equal to 0. And I actually do believe this one is factorable, right? So let's go ahead and factor this. Right, we have a negative in front. I would get rid of that negative by dividing everything by negative 1, right? And that's going to get us an x squared minus 6x plus 8 equals 0. And then that's going to get us x minus 4 and x minus 2 equals 0. All right, so factors of 8 that add to negative 6 are negative 4 and negative 2, right? So that's how we got those numbers. And then when you set both of these factors equal to 0, x minus 4 equals 0, x minus 2 equals 0, we get x equals 4 and x equals 2, right? So I get 2 comma 0 and 4 comma 0 as our x-intercepts. Remember, intercepts should always be written as ordered pairs, so I'm going to go ahead and plot those points. Right? This is enough information to actually sketch our parabola, but again, we have more information that we need to find. I need to find the y-intercept. You could plug in 0, right? So I could find f of 0, and that's going to get us a negative 0 squared plus 6 times 0 minus 8. But once again, you can also just look at your c value, right? Your c value here is negative 8, so I know my y-intercept is going to be at 0 comma negative 8. All right, and then we plot that point. It's going to be a little bit off our graph right there. And because I have an axis of symmetry, I know that since that point, that y-intercept is 1, 2, 3 units from the axis, I'm going to go 3 units in the other direction. And we also have a point right there to more accurately draw that graph, right? So then our parabola is going to look something like this. All right, let's do another one. All right, so same exact information. This one's in quadratic form. So we have an a, b, and a c, right? So again, there's nothing in front of x squared, so that is our a. Our b is going to be this negative 4, and then our c is going to be this positive 3. All right, so once again, I'm going to find h equals negative b over 2a. And so I have a negative 4 over 2 times 1, and that's going to get you a positive 4 over 2, which is 2. All right, so that means the x-coordinate of my vertex is 2. I can go ahead and find f of 2 to find the y-coordinate of our vertex. So that's going to be a 2 squared minus 4 times 2 plus 3. And that's going to get us a 4 minus 8 plus 3. And that's going to get us a negative 4 plus 3. And so that gets us negative 1. All right, so we get 2 comma negative 1. I'm going to plot that point. It's going to look something like that. All right. Our axis of symmetry, once again, you're just going to look at the x-coordinate of your vertex. It's going to be x equals 2. And then I'm going to go ahead and draw that on the graph. All right, x-intercepts, you're going to set your function equal to 0. So we get x squared minus 4x plus 3 equals 0. All right. And now we can go ahead. This one is also factorable. So this is going to be x minus 3 and x plus 1, right? So minus 1 equals 0. So that means I get x equals 3 and x equals 1 as the x values of my x-intercept. So this is going to be 3 comma 0 and 1 comma 0, right? So I have a point right there and a point right there. And then to find the y-intercept, again, you can plug in 0 for x squared and 4x, but once again, that's always just going to get you your c value, which is 3. So without even doing any math, I can find my y-intercept at 0 comma 3, right? I can plot that point right now. And then once again, since I know that this y-intercept is 2 units from our axis of symmetry, I'm going to go 2 units in the other direction, and I'm going to plot that point as well. All right, and then it's going to look something like that, the graph of our parabola. All right, so hopefully you're seeing that it's not too bad. There's just, compared to the last lesson that we just did, there's a lot more math that goes into it, right? So you're going to have to show a lot of work for these kinds of problems. All right, let's do another one. So once again, your vertex, same exact process. This is in quadratic form. A is 2, B is 8, C is 7. So I'm going to do h equals negative b over 2a. So negative 8 over 2 times 2. So negative 8 over 4, which is negative 2. All right, so I get that the x-coordinate of my vertex is negative 2. I can go ahead and plug that into my function. So I want to find f of negative 2 to get the y-coordinate. And this is going to be 2 times negative 2 squared plus 8 times negative 2 plus 7. All right. And then negative 2 squared is 4, and 4 times 2 is 8. So I get 8 plus 8 times negative 2 is 16, or negative 16. So I'm going to say 8 minus 16, and then plus 7. 8 minus 16 is negative 8, plus 7 is negative 1, right? So I get the y-coordinate of my vertex is negative 1. Let's plot that point. All right. Once again, your axis of symmetry, you're going to use the x coordinate of your vertex, so we're going to get x equals -2. All right, something like that. Your x-intercepts, once again, we can maybe try to factor this. All right, let's see if it works in this case, right? So take your function, 2x squared plus 8x plus 7, set it equal to 0, and I'm going to do 2 times 7, which is 14. All right, do we have factors of 14 that add to 8? Doesn't look like we do. So we're going to have to do either completing the square or quadratic formula, right? I personally would rather do quadratic formula for this one, right? Because to do completing the square, we would have to divide everything by 2, right? And then you'd be left with 7 over 2. You don't really want to be left with a fraction here, so let me go ahead and erase that. I'm going to erase that as well, and we're going to do quadratic formula, right? So I'm going to do x equals -b, so -8 plus or minus the square root of 8 squared, so b squared minus 4ac minus 4 times 2 times 7, all over 2a, so all over 2 times 2, right? And so that's going to get us -8 plus or minus the square root of 64 minus 4 times 2 is 8, and 8 times 7 is 56, divided by 4, all right? And then we're left with -8 plus or minus the square root of 64 minus 56 is 8 over 4, and then 8 we can simplify, right? So this is going to get us the square root of 4, square root of 2, and the square root of 4 is 2. So that means I get -8 plus or minus 2 square root of 2 over 4, and these do simplify, right? 8 and 4 is going to become a 4 and a 2, and that 2 is going to become a 1, right? So I need to cancel the same factor out from everything. So this is going to be -4 plus or minus the square root of 2 over 2. I know a lot of work for this one, but some of them do get that complicated. All right, so then I'm going to write in as an ordered pair, -4 plus minus the square root of 2 over 2 comma 0, right? And I'm not going to plot that on my graph just because I don't know where that's going to be, right? That's going to be somewhere kind of close to our axis of symmetry, right? Probably around that region right there. But I don't know exactly, right? I'd rather plot the y-intercept to have a more accurate graph. All right, so let's find the y-intercept. Now this one is super easy, right? Because all you have to do is look at the c value again, right? It is in standard quadratic form, so it's just going to be 0, 7, right? And I'm going to plot that point. It's going to be up there. Again, it's 2 units from the center, so that means I'm going to go 2 units in the other direction, plot a point, and then it's going to look something like that, right? And that's a good enough sketch of our parabola. All right, so sometimes to do some fill in the blanks, we're gonna give you some information of a quadratic function, and we'll ask you to write the equation, right? And then typically we ask you to write it in this form, right? The y equals a x minus h squared plus k, right? So usually we're gonna give you a vertex and a point. All you have to do is plug in the vertex and plug in the point into this equation. Solve for the a value. You're going to see that that's the only thing that's missing. And then you're going to plug in just the vertex and a, right? You're not going to need your point xy, right? Just the vertex and just a. All right, so let's have a look at this, right? Our vertex we can label as hk. And then it's going to go through this point xy, right? So the goal here is to write an equation, right? And your equation should be in the form of y equals a x minus h squared plus k, all right? So let's go ahead and plug in all the information that we have, right? This 1 is going to go in for that h. This 2 is going to go in for that k. This 3 is going to go for the x. And then this -6 is going to go for the y, right? So then we get -6 equals a, right? A is the only thing that we don't have something filled in. 3 minus 1 squared plus k, so plus 2. And then we're left with a -6 equals a times 2 squared plus 2, right? I'm going to subtract 2 on both sides. We get -8 equals a times 2 squared is 4. and then divide by 4 on both sides, and then I get a equals -2. All right, so that's an important piece of information because now I can plug it into that a in our function. All right, and then hk, I'm going to plug this into that as well, right? But we don't need to plug in our point. We only needed that to find the a value, right? So you're still going to have x and y in your final answer. This is going to be y equals -2, x minus h, so x minus 1 squared, plus k, so plus our k value was 2, right? So that's the equation in vertex form, right? So let's do the exact same thing with the next one, right? So we have a vertex going through, we have a vertex hk, and it's going through -6, 5, so xy. And then once again, I'm going to plug in all the information that I have, right? So I have 5 equals a, x minus h is going to be -6 minus -4, so plus 4, plus k, so plus 11. All right, so then that's going to get us 5 equals a times -2 squared plus 11. We can subtract 11 on both sides, and then you're left with a -6 equals a times -2 squared is going to be a 4a, right? -2 times -2 is 4. And then divide both sides by 4, and then you get a equals -6 over 4, which you can simplify that, right? Divide the top and the bottom by 2, and then I get a equals -3 over 2. All right, so then once again, I'm going to plug that into our equation, right? We still need the h and the k, and I need the a, but once we have the a value, I don't need that point xy anymore, right? So what we're going to do is we're going to say y equals -3 over 2, x minus h squared. So x minus -4 is x plus 4 squared plus 11. All right, and then that is the equation of our quadratic function. All right. Another type of question in this lesson that we'll ask you is we're going to ask you to write the quadratic equation in standard form by completing the square. Now, I might show you completing the square for this one, but really I just want you guys to know how to put it in vertex form, right? We're not really going to ask you like we did many months ago on a test if, right, to do it using completing the square, right? But these are the steps for completing the square. But I'm just going to show you how to write it in standard form or in vertex form. All right. So again, something that we'll ask here is write this equation in standard form. Again, that for the sake of this lesson is vertex form, right? And then we're going to find the vertex, the y-intercept, the x-intercept, and the axis of symmetry. All right. So same information that we did before. To write it in vertex form, remember, I want to go from y equals ax squared plus bx plus c, and I want to turn that into y equals a times x minus h squared plus k. All right. So what we need is a vertex, right? So to find the vertex, again, I need to know what a, b, and c are. So a is going to be 1, b is -6, and c is -3. All right. So then this is going to be h equals -b over 2a, so -6 over 2 times 1, and that's +6 over 2, which is 3. So that means I know my vertex is going to have an x coordinate of 3, right? And then so to find the y coordinate, I'm going to plug that in, and we're going to get a 3 squared minus 6 times 3 minus 3. And that's going to get us a 9 minus 18 minus 3. So that's going to get us a -9 minus 3, which is -12. So that means my vertex is -12, right? But keep in mind, we were asked to write this equation in standard form, right? Or vertex form. So that means further than this, I'm going to need to label this as h and k. And I'm going to plug in those numbers in that formula there, right? Keep in mind the a in the quadratic form is the same a that's in the vertex form. So a in this case is 1. So my equation in vertex form is going to be y equals a. You can write the 1 if you want to, but if you're multiplying by 1, you don't have to write it. I'm just going to write it so that you guys see what's going on. In parentheses, x minus h. The h coordinate of our vertex is 3. All right, squared plus k. It's plus negative 12, so that's a minus 12. All right, and that is our equation in vertex form. All right, and then from here, let's just find all of the rest of the necessary information, right? Let's find the axis of symmetry. I'll typically abbreviate that AOS, right? So my axis of symmetry is just going to be x equals the h coordinate of our vertex, so x equals 3. The next easiest thing to find is going to be the y-intercept, right? Now you're always going to use the c value, right? So it's going to be negative 3, so it's going to be 0, comma, negative 3, all right? Big mistake that I see a lot of people make is that they use this number that's at the end of the vertex form. That does not represent your y-intercept, that represents the y-coordinate of your vertex, right? So keep in mind it's only the last number in standard quadratic form like this, all right? And now lastly, let's find our x-intercepts. You can do this however you want, either using the original or using the vertex form. If you use the original, you can either factor, complete the square, or use the quadratic formula. If you use the vertex form, I would just set it equal to 0 and then solve by square rooting. So I'll show you what that looks like. I'm going to take the x minus 3 squared minus 12 equals 0. All right, so I'm taking this and I'm setting it equal to 0, right, to find my x-intercept, right? And then I'm going to add 12 on both sides. And then we're going to get x minus 3 squared equals 12. Square root both sides, and then I get x minus 3 equals plus or minus the square root of 12. And then I can add 3 on both sides. Also keep in mind you need to simplify square root of 12 as much as you can. So I get 3 plus minus the square root of 12, but that becomes the square root of 4 and the square root of 3, which the square root of 4 becomes 2. So I get x equals 3 plus or minus 2 square root of 3, right? Which as an ordered pair is going to be 3 plus minus 2 square root of 3, comma, 0. All right? And then that finds all of our necessary information. Just for the sake of consistency, I might ask you this during class, I might not, but I'm just going to sketch a graph, right? So let's plot all of our necessary information, right? So 1, 2, 3, and then I'm going to go down 12. I'm just going to say that that's about 12, right? I'm going to go by 4s, right? That's our vertex. Our axis of symmetry is at positive 3. Our y-intercept is at negative 3, which is going to be about there. And I don't want to graph those x-intercepts because that's a complicated number to graph, right? And then I'm going to go 1, 2, 3 units on the other side. And then we get a parabola that looks something like this, all right? All right, so hopefully we're getting the idea. Let's try the exact same thing here. All right, so again, we're asked to put it into standard form. Again, for the sake of this lesson, that's the same as vertex form. All right, so this right now is in quadratic form. I want to turn that into y equals a times x minus h squared plus k. So to do that, I need to find the vertex. So I'm going to do negative b over 2a. All right, so a is 1, b is negative 4, and c is negative 7. So I'm going to do h equals negative b over 2a, which is negative 4 times 2 times 1, or over 2 times 1. And that's 4 over 2, and that equals 2. So we can fill out information with our vertex, right? So our vertex is going to be 2 comma something, right? To find out what that something is, you're going to plug into that function right there, right? So then this is going to be a 2 squared minus 4 times 2 minus 7. So it's going to be a 4 minus 8 minus 7. So negative 4 minus 7. So we get negative 11, right? So I get 2 comma negative 11 for the vertex. And that means our equation in vertex form is going to be y equals a. Keep in mind a in this case is 1. X minus h, so x minus 2 squared plus k, so plus negative 11 is minus 11. Remember, vertex is h and k. All right. And then from here, we can also find our axis of symmetry. So our axis of symmetry is going to be x equals the x-coordinate of our vertex, right? Another super easy piece of information we can find is the y-intercept. Just use your c value. That's going to be 0, -7. And then lastly, I want to try to find the x-intercepts, which once again, you can either use your equation in vertex form or you can use the original. I'll show you using the original. If we did x squared minus 4x minus 7 equals 0, you can solve that however you want. I prefer with this one to do completing the square because if you remember from way back, right, kind of the middle of chapter 1, I had showed you guys when a is 1 and b is even, it's best to do completing the square. If you do quadratic formula, you're going to have like an extra factor to simplify, right? And you're probably going to get an answer that's unsimplified, and we should all be arriving at the same answer. Right? So let me complete the square for this one. Add 7 on both sides. I get x squared minus 4x plus a blank equals 7 plus a blank. And this is going to get us a 4, right? Take b over 2 squared, and that's going to get you a positive 4. And then we get x minus 2 when we factor the perfect square trinomial equals 11. Square root both sides, and I get x minus 2 equals plus minus the square root of 11. And then I can add 2 on both sides. And then that's going to get us an ordered pair of 2 plus or minus the square root of 11, 0. All right. So that's all the information that we asked for. Again, you can sketch a graph if you would like. But yeah, that's it for this problem. All right. The only time where these might get a little bit more complicated is if the middle term is or results in a fraction, right? So when you do negative b over 2a in this one, right? So it's going to be 1, -5, and -4, right? A, b, and c. I'm going to do h equals negative b over 2a. This is going to be negative 5 over 2 times 1, which is a positive 5 over 2. And there's nothing more you can do to that. So your vertex is unfortunately just a fraction. So it's going to be 5 over 2 comma something. All right, and again, I'm going to plug that number into our equation. And this is going to be 5 over 2 squared minus 5 times 5 over 2 minus 4. And so this is going to get you 25 over 4 minus 25 over 2 minus 4. All right, to simplify this, I do want a common denominator. I'm going to multiply this by 2 and 2. And this is going to get us 25 minus 50 over 4 minus 4, right? Which is going to get you a negative 25 over 4 minus 4, right? And then I'm going to again write this over 1 to get a common denominator. I'm going to multiply the top and the bottom by 4. And then I'm going to get a negative 25 minus 16 over 4. And that's going to get you a negative 41 over 4. All right, a lot of steps to find the actual vertex, right? That was just the vertex for that part of it, right? We get negative 41 over 4, right? In vertex form, right? Now that I have the vertex, all right, all I have to do is plug everything in. So I get y equals a, all right? So a is 1 in this case, x minus h, so x minus 5 over 2 squared, plus k, so plus negative 41 over 4 is going to get you minus 41 over 4, all right? From here, the next easiest thing to get is the axis of symmetry, which is going to be the x-coordinate of your vertex. So I get x equals 5 over 2. The next easiest thing to get is the y-intercept, which again is your c value, right? You don't have to do any math to find that. It's 0, -4. And then I think this one's actually a nice one that does factor, right? So you can set your original, although, wait, actually. No, actually, I don't think this one does factor, actually, right? So I would do quadratic formula or completing the square. But again, I wouldn't complete the square for this one just because the middle term is an odd number, right? And I don't want to do completing the square and do 5 over 2 on both sides, right? I would rather just plug everything in and get a singular answer right away. So I'm going to do x equals negative b. So negative 5 plus or minus the square root of b squared, so negative 5 squared, minus 4ac, 4 times 1 times negative 4, over 2a, so over 2 times 1. All right, and that's going to get you 5 plus or minus the square root of 25 plus 16 over 2, and that's going to get you 5 plus or minus the square root of 41 over 2. All right, so it does not simplify, right? So I was mistaken, does not factor. All right, so I would set my ordered pairs as 5 plus or minus the square root of 41 over 2, comma 0. All right, and that's all the information that we were asked of. All right, so that's all we have to do in this one. Again, if you needed to sketch a graph, you would just use the information that you have and then plot some points and then draw your parabola, right? So more math heavy this lesson, right? I can tell that this one might shake some of you up, right? But I know it's a lot of steps, but you just need to remember what each part represents, right? Each part of it isn't really super complicated. Like just finding the vertex, okay, negative b over 2a, plug it in, right? Just finding vertex form, get your vertex, plug it in, right? Just finding the axis of symmetry, you just need the x-coordinate of your vertex, right? But it's piecing it all together and doing everything in one problem that could get a little challenging, right? So take your time, right? We're going over this over a course of like 2 or 3 classes, right? So shouldn't be too daunting right away, hopefully.